if you are given a question on mathematical induction in a mass CBT test, you know that you have limited time, right? So approximately you need like 60 seconds maximum to answer that question, and you don't need to waste time on that question, right? Because actually you're not actually going to prove something that's waste your time, right? You need to finish on time. So in this video I'm going to give you a 3-step approach for you to ace questions that are related to objective questions that test your knowledge of the PMI, also known as the principle of mathematical induction, and then also leading to proof by mathematical induction. Right? So one stuff about this proof by mathematical induction is that it exists if you are given an expression and then you are now asked to prove it using PMI, right? It exists for all natural numbers. That's the values of n for that expression and natural numbers for that PMI, right? So for all n, which is what, a member of the set of what, natural numbers, which could also write as for all positive integers, for all numbers greater than or equal to 1, right? So to prove an expression using PMI, first of all you substitute n equal to 1, and then if maybe that stuff after substituting n equal to 1 is now true, you now substitute n equal to k, and then substitute n equal to k plus 1. But in the CBT exam, they're not going to ask you to prove, right? So you don't have to waste your time. The only thing they're going to test you on is, do you know the steps that are required for you to prove an expression using the PMI? That's the question. That's what they're trying to test, because you cannot start proving. They're not going to mark your work. They're just going to give you 4 different options and expect you to give them an answer, right? So as I said earlier, you first of all substitute n equal to 1, and then if the relationship is true, you now test at n equal to k, then at n equal to k plus 1. So what's the importance now? Let's say you're giving this question in exam and it says to prove, I don't want to write so much, it says to prove by mathematical induction that the summation of r from r equal to 1 to n is equal to half n into n plus 1 for all positive integers. I hope you're following me. The assumption that the summation of r from r equal to 1 to k is equal to half k into k plus 1 leads to, that's the question. So what is happening here now? This is a summation, and I hope you understand the meaning of this. If you don't understand, let me tell you. This stuff right here is just trying to tell you from r equal to 1 to what, n, you are just adding. That's 1 plus 2 plus, because this is the function here, r. You are just adding. If maybe it was r squared, you will do 1 squared plus 2 squared down till n. So what's my point? My point here is that you now see that the assumption that, because after testing at n equal to 1 and it is valid, you are now free to do what, assume that n is equal to k, which the question has given you. So you don't waste time. It now says the assumption that the summation of r from r equal to 1 to k is equal to half k into k plus 1 leads to. So what you now do is to substitute what, k plus 1 anywhere you have n, because that's the next step that will now finalize your proof. So what you simply do, that implies that 1 plus 2 plus 3 plus down to what, k plus 1, because you are now finding the sum down to k plus 1, would that be what, 1 over 2. Remember, look at the original expression here. Let me write it here, half n into n plus 1. So anywhere you see n, replace with k plus 1. That will be k plus 1 into k plus 1 plus 1. Are you following? And then with that, you now have equal to half into k plus 1 into k plus 1 plus 1 is what, k plus 2, and that is the expression. When you now do this, you now induce. We are not doing the proof. This is just what you are being asked to do. Because at n equal to k, if that n equal to k is valid via the proof process, the next step to now take is to do what, That's what is leading to, is to substitute what? K plus 1, and that's at n equals to k plus 1. Do you understand? So that's the answer to the question. So using the principle I just gave you now, answer this. If we have the summation of r squared from r equal to 1 to n as 1 over 6 n into n plus 1 into 2n plus 1, right? The assumption that the summation of r squared from r equal to 1 to k is equal to 1 over 6k into k plus 1 into 2k plus 1 leads to, now pause the video, attempt it. Have you paused? Okay. So what we just simply do here is to substitute what? N equal to k plus 1, because the expression has substituted. Comparing with this, n is equal to k, then at n equal to k plus 1, that is where it is leading to, for that proof to hold, for the original expression summation of r squared from r equal to 1 to n to be equal to what? 1 over 6n into n plus 1 into what? 2n plus 1. So given that expression now, 1 over 6n into n plus 1 into 2n plus 1, anywhere you see n, you replace it with what? K plus 1. And when you are doing this substitution, be very careful. So what would that be? 1 over 6 into what? K plus 1. Are you following? Because this n now is what? K plus 1 into what? N, which is k plus 1 into what? 2 into what? N, which is what? K plus 1 plus 1. Then after that, what you now simplify, that will be 1 over 6 into k plus 1 into k plus 2. Then on expansion of this, you have what? 2k plus 2 plus 1. Then that will now give you 1 over 6 into k plus 1 into k plus 2 into what? 2k plus 3. So this is where it's leading to. After substituting n equal to k, you now substitute what? N equal to k plus 1. Because with that, you will now, when you now prove it, that's not what I'm teaching in this video. I'll still in detail later on, I'll give a detailed video on how to prove an expression using PMI, right? So at the end of the day, you will now induce, and then comparing the values, they now have to be equal at some point. That just get the main point. Yeah, right? So on substituting k plus 1, you have what? 1 over 6 into k plus 1 into k plus 2 into 2k plus 3. I don't know if you are getting it. Then let's say you are giving this first dividend attempt to, right? The summation from r equal to 1 to n for r times r factorial, that's r times r factorial, is equal to n plus 1 factorial minus 1, where n is a member of what? Set of real numbers, right? Because for PMI, we're talking about natural numbers, right? Sorry, set of natural numbers, n. So it now says the assumption that the summation of r times r factorial from r equal to 1 to k is equal to k plus 1 factorial minus 1 leads to what? Substitute k plus 1 anywhere you see n in the original expression, and the original expression was what? N plus 1 factorial minus 1. So on substituting k plus 1, it will be what? K plus 1, which is the n, plus 1 factorial minus what? 1. And then on simplification, you have k plus 1 factorial minus 1. Then you now have what? K plus 2 factorial minus 1. That is where it's leading. That is what helps you to get your final proof. Then at the end of the day, you see that if maybe I ask this in an essay, at the end of the day, you will now show that, you will now conclude that yes, for all n greater than or equal to 1, the summation of r times r factorial from r equal to 1 to r equal to k is equal to what? To r equal to n is equal to n plus 1 factorial minus 1. Do you understand? Then, moving on, you should be able to get another thing. Let me just take this last one, right? based on this summation. If you have k, so starting with n, and then you have r minus 1 into 3r minus 2, right, equal to n squared into n minus 1. For all n, which is a member of the set of natural numbers, the summation of r equal to 1 to k for r minus 1 into 3r minus 2 is equal to k squared into k minus 1 leads to pause the video and attempts. So that means anywhere you see n, replace with what? K plus 1. So that will now be what? K plus 1 squared into k plus 1 minus 1. Are you following? Because the original expression says is equal to what? N squared into n minus 1. So I'm doing that, you now have that k plus 1 all squared into what? K plus 0, which is what? K. Do you get? So that will be k into k plus 1 all squared. Then if you expand k plus 1 all squared, what will you get? Sorry, that's k plus 1 into k plus 1. That will be k into k times k is what? K squared plus 1 times k, k, plus 1 times k, k, then plus 1 times 1, 1. Do you get? Which will now be equal to what? K cubed. Let me resolve what is inside first. So that will be k squared plus k is what? 2k, then plus 1. Then open the bracket. You will now have what? K times k squared, that's k cubed, plus k times 2k, that is what? 2k squared, and k times 1 is what? K. So this is what it leads to. Do you understand? So that's the application. Then the same thing applies to when they are talking about divisibility. When you see a question and then they are talking about integer multiples, integer multiple, or they could say divisible by. Let's take a question. And it says the truth that 10 to the power 2n plus 1 plus 1 is an integer multiple of 11 is established if the assumption 10 to the power 2k plus 1 equal to 11m leads to, are you following? So that's what the question said. So this is PMI. So if you now want to prove it, the next step is to substitute what? K plus 1. But let me give you the options that were given in that question. And option A said 11 into 10 100m plus 9. Option B 11 into 100m plus 99. Option C 11 into 10m plus 9. And option D 11 into 100m minus 9. So you can see that first, as I said, you substitute k plus 1. Let me substitute first. I'll tell you what next to do. Remember that the expression given to you is what? 2 to the power n plus 1 plus 1. So if you now substitute n as what? K plus 1, because the question has already given you the expression when n is equal to k. Then at n equal to k plus 1, it will be what? 10 to the power what? 2 into what? K plus 1. I'm now substituting n as what? K plus 1 plus 1. Are you following? Then 2 into k plus 1 is 2k plus 2. Then plus 1 plus what? Plus 1. Are you getting it? So at the end, you now have 10 to the power what? 2k plus 3 plus 1. This is a possible answer, but based on the options they are given. That's when we are solving questions, look at the options, especially in a CBT situation. Then look at the expression given, and it says 10 to the power 2k plus 1 is equal to what? 11m. And I hope you know the meaning of this expression. It means that for n equal to k, then is a multiple of what? 11. That means it's divisible by 11. Because if a number, for example 55, is divisible by 11, is it not? Because you can factor out 11, right? So that's the idea. So using the expression, look over here, that 10 to the power 2k plus 1 is equal to 11. You can now relate it to this, because you can see that the answers given to you are in terms of m. Are you following? So you can now break this 10 to the power 2k plus 3 plus 1 as 10 to the power what? 2k plus 1 plus 2. Still the same thing, then plus 1. And then using power law of indices, that's addition law, which says that a to the power x times a to the power y is equal to what? A to the power x plus y. Are you getting it? So this 10 to the power 2k plus 1 plus 2 can now be splitted to what? 10 to the power 2k plus 1 times what? 10 squared plus 1. Then 10 squared is what? That will be 100 into 10 to the power 2k plus 1 plus 1. Are you seeing what's happening? So that now that from the original expression given in terms of k, that's 10 to the power 2k plus 1 equal to 11m. This plus 1 can now cross over. Are you following? So now the 10 to the power 2k plus 1 is equal to 11m minus 1. Are you getting? So anywhere you now see 10k, 10 to the power 2k plus 1, you now replace it with what? 11m minus 1. And that will now give you what? 100 into 11m minus 1 plus 1. 100 times 11m, you could just write it as 100 into 11m. 100 times minus 1 is what? Minus 100, then plus 1. You simplify it, you have 100 into 11m minus what? 99. Then you can see that 11 is a factor, so factor out 11. 100 into 11m divided by 11 will give you what? 100m minus 99 divided by 11 will give you what? 9. And that is the answer. That's what it leads to. That will now help you to get to now prove it. Do you get it? So that's the answer to the question, and in this case the answer is option D. Are you getting it? Then now let me solve another question still related to this divisibility. I want you to pause the video and attempt this question. And it says to prove by PMI that 5 to the power 2n plus 3n minus 1 is divisible by 9. The assumption that 5 to the power 2k plus 3k minus 1 is equal to 9m leads to, pause and attempt please. So what do? Substitute what? N equal to k plus 1, because that's the next step after the question has already substituted k, right? So that will be 5 to the power 2 into k plus 1 plus 3 into k plus 1 minus what? 1. And then if you now simplify that, 2 into k plus 1 is what? 2k plus 2, then plus 3 into k plus 1 is 3k plus 3 times 1 is what? 3, then minus 1. So what then that now give you 5 to the power 2k plus 2 plus 3k, then 3 minus 1 is what? Plus 2. Do you get it? So I've substituted n as what? K plus 1. Then you can see that the options when I checked is still in terms of m, just like what we just solved some minutes ago, right? So what do? Relate this now to this. You can see that you can break down this 5 to the power 2k plus 2 in terms of what? 5 to the power 2k. Do you get what I mean? So this 5 to the power 2k plus 2, using the addition law, we can now split it as what? 5 to the power 2k times 5 to the power 2 plus what? 3k plus 2, because using multiplication law, right, you can add the powers. So I just splitted it. So 5 squared is 25. That's 25 into 5 to the power 2k plus 3k plus 2. Then remember the expression that was given to you, which says what? 5 to the power 2k plus 3k minus 1 is equal to what? 9m. So you make 5 to the power 2k the subject. And if you make 5 to the power 2k the subject, what happens? This crosses. That means that 5 to the power 2k will be what? 9m plus 1 minus 3k. Because the 3k crosses over to be negative. So anywhere you now have 9m 5 to the power 2k, you have, it will now be 25 into 9m plus 1 minus 3k plus 3k plus 2. Are you getting it? Then if you expand, it will be 25 into 9m plus 25 times 1 is what? 25 minus 25 times minus 3k minus 75k plus what? 3k plus 2. Then with that now, it will be 25 into 9m. Then this 25 and this 2 can go together to be what? 27, isn't it? Then minus 75k plus 3k is minus 72k. 25 plus 2 is what? 27. Then you can now see that 9 is a factor. If you factor 9 out of 25, that is 25 into 9m divided by 9. You are factorizing. It will be what? 25m. Then minus 72k divided by 9 will be what? Minus 8k. Then positive 27 divided by 9 is what? Is 3. So this is where it's leading to. So it's a very simple thing. Once you are given the question, you substitute what? N equal to k plus 1. Then you now make the expression similar to the what was given to you, which is this 5 to the power 2k plus 3k minus 1 equal to 9m. You now express it in that form. You see what I did with the powers? Do you get? And then at the end of the day, you have your answer. Do you get it? Then is another question again I have based on this divisibility, but it was asked indirectly, right? And it says to prove by PMI that n squared plus n is even for all n which is a member of set of natural numbers, right? The assumption that k squared plus k is even leads to, so you can see what the question said, even. What does it mean for a number to be even? That means it's divisible by 2. Are you following me? It's divisible by 2, and if it's divisible by 2, you can still follow that same principle. We can now say that what? K squared plus k is equal to what? 2m. Because on substituting n as k, it still has to be what? Divisible by 2. Because this the aim of this stuff is that for all n greater than or equal to 1, the function, the expression, the statement is what? Is valid, right? So the next step is anywhere you now see n, substitute k plus 1, and on doing that you have what? K plus 1 all squared plus what? K plus 1. I hope you are following. So expand k plus 1 all squared, it will be what? K plus 1 into k plus 1, right? K times k is what? K squared. 1 times k, k. K times 1, k. 1 times 1. So that's what? K squared plus what? 2k plus 1. Don't forget this k plus 1 over here. So it will be k squared plus 2k plus 1 plus what? 1. Which will be k squared, that's plus k, right? Plus k. You're following, right? So that's k squared plus 3k plus 1. Do you get it? This is the expression that was gotten when we substituted n equal to k plus 1. Then you will now relate it to when k was just substituted. You are seeing k square here, you are seeing k square here, you are seeing a relationship. You can now see that this positive k can shift it to the right hand side. Are you getting me? And then it will now be what? You have k squared plus k equal to 2m. If you move this here, it becomes that k squared is what? 2m minus k. So if you take that now and substitute it in the expression when you substituted k plus 1 in the n function, what happens? If you substitute k squared as 2n minus k to be what? 2n minus k plus 3k. This is connected to this, so plus what? Plus 1. And then what does that give you? 2n minus k plus 3k is what? Plus 2k. Because minus 1 plus 3 is plus 2. Then plus 1. Right? Wait. So basically what happened there now was we had k squared plus, let's be very careful, this is k squared plus 2k plus 1. Are you seeing where the error is from? K squared plus 2k plus 1. So this 1 plus this 1 is what? 2, because k plus 1 all squared is k squared plus 2k plus 1. Then we now added k plus 1. That's how we now got what? K squared plus 3k plus 2. Are you following? Then from there now, so that means what we will have here is 2m plus 2k plus 2. That was the omission, right? So you cannot factor out 2, it will now be what? 2 into m plus k plus 1. This is the leading expression. Are you getting it? Very good. Then next question I'm about to show you now is based on powers, and it says for 2 to power n, 2 to power n is greater than n, right? So the assumption, this one answer, you can answer it in seconds. The assumption that 2 to power k is greater than k leads to what? So what do? Anywhere you see n, we replace it with what? K plus 1. So that will be 2 to power k plus 1 greater than what? K plus 1. And you've answered the question, because these are the steps that you need to take for you to end up with your correct proof. That's what they are just asking. If you look at the option, you see it. Do you get it? Then lastly, more question on this divisibility, and it says 3 to power 4n plus 2 plus 5 to power what? 2n plus 1 is divisible by 14. The assumption 3 to power 4k plus 2 plus 5 to power 2k plus 1 equal to 14m leads to, so same principle, substitute what? K plus 1 in n. Anyway, you see n, replace with k plus 1, because this expression gives you for what? N equal to k. So that will be 3 to power 4 into k plus 1 plus 2 plus 5 to power 2 into k plus 1 plus 1. So now what then happens if we expand it to be 3 to power 4? If you expand, that will be 4k plus what? 4 plus 2 plus 5 to power what? 2k plus 2 plus 1. So no need to start simplifying it, because you now have to find the connection between when n equal to k was substituted and when n equal to k plus 1 was substituted. Are you getting it? So you can rewrite this as 3 to power 4k plus 2 plus 4 plus 5 to power 2k plus 1 plus 2. Then using the power law, you can maybe now put this in bracket. Are you following? So using the power law that says a to power x times a to power y is a to power x plus y, you can now say that this is 3 to power 4k plus 2 multiplied by 3 to power 4 plus 5 to the power 5k plus 1 multiplied by what? 5 to power 2. Are you getting it? So at the end, what happens? 3 to power 4 is what? That is 81 into 3 to the power what? 4k plus 2. Then plus 25 into 5 to power what? 2k plus 1. This could be your answer. But if maybe the answer is now put in terms of n, of m, right? You come to this equation now and make n the subject of the formula based on the options you see. Do you get? If maybe you are seeing that the option is a mixture of m and 5 to power 2k plus 1, right? You make 3 to the power 4k plus 2 the subject. Just depending on what you have. Once you just have this expression, which is here, your job is done. Your job is just to go to the original expression and make any the subject, and then you've gotten it, right? So what then happens here? From 3 to the power 4k plus 2 plus 5 to the power 2k plus 1 equals 14m. If we make 3 to the power 4k plus 2 the subject, what we have, that will be 14m. Sorry, this is 81. 14m minus 5 to the power what? 2k plus 1 plus 25 into 5 to the power what? 2k plus 1. That's all. So that's 81 into 14m minus 81 into 5 to the power 2k plus 1, then plus 25 into what? 5 to the power 2k plus 1. You can now factor out 5 to the power 2k plus 1. So that will be 81 into 14m minus 5 to the power 2k plus 1. If we now factor out, to be what? 81, because this divided by this will give us positive. Then 25 into 5 to the power 2k plus 1 divided by what do you call it? 25 into 5 to the power 2k plus 1 divided by negative 5 to the power 2k plus 1 gives us what? So you can see now that 81 into 14m minus 5 to the power 2k plus 1 into 81 minus, because plus divided by minus is minus, so that's 25. Do you get the factorization? This connects to this. So that will be 81 into 14m minus what? 5 to the power 2k plus 1 into 56. Do you get? And then you can now factor out 14. If you factor out 14 to give us what? 81m, because this divided will leave us with 81m. Then 5 to the power 2k plus 1 divided by into 56 divided by 14 will be what? To be 4. To leave us with 4 into what? 5 to the power 2k plus 1. And this is the answer. This is not a past question. I just brought something that is more complex so that you can have a better understanding, so that any question you are given, you'll be able to get it, right? So this is it. So even though you wanted to make 5 to the power 2k plus 1 the subject, you can move the positive 3 to the power 4k plus 2 to the right, and 5 to the power 2k plus 1 will be what? 14m minus 3 to the power what? 4k plus 2, and then you substitute. That's just the principle, right? Thank you so much for watching this video. Please, if you've not subscribed to this channel, please do well to subscribe by clicking the subscribe button, like and share this video. And if you have any questions that relate to stuff like this, contact me. My number is on the screen, right? And I'll be very happy to respond. Thank you so much for watching once again, and have a nice day.